so I would cross out worksheet and write notes on there. I didn't catch that when I was doing that. So we have section 4.5 notes. Again, this book puts so much in one section. We've broken it up into a lot. So we are going to learn to write the sine and cosine equation. So we need to first remember what the sine and cosine equation looks like. So I have y equals plus or minus. What's that plus or minus do? Reflects it over the horizontal axis, correct? Okay. A, what's A? Amp. And the amp is the distance from the center of the curve to the top and the center of the curve to the bottom, right? Okay. And then I'm going to put sine slash cosine because this works for both of them, correct?
Yes.
Okay. So then I have parenthesis plus or minus. Actually, I'm not even going to do plus or minus b because of the fact that we learned that with a negative b on cosine, it didn't even affect it, right? And a negative b on sine, you could factor it out and make it a negative a and have the same thing happen, right? So when you write it, you're never going to have a reflection over the y-axis. You're just going to use them normal. So we will have b x minus h plus k. Now you notice the b is factored out of that, yes? Okay, so when we fill it in, it's going to look like that, but that's not going to be done. When we finish it, we will have plus or minus a sine slash cosine, and we're going to have to distribute our b. So when we distribute our b, it becomes a c or some other random variable. And h is the left or right movement from a 0, right? And k is the up or down movement of the axis, and then we count from there. So we're just going to go backwards. Every graph you get, you will be required to write both a sine and cosine equation for the graph. Because we've talked about it, they're the same curve, right? Just translated. So every graph you get is 1.5 problems because some of those things are the same. Amp isn't going to change whether it's a sine or a cosine, is it? No. Period isn't going to change, so the b is not going to change. The k isn't going to change. The only thing that's possibly going to be, well, always will be different is h, and may be different is a reflection. So, and we'll go through that all, but I wanted just to review that. The first one we have here is we just says sine function on this one. I didn't give you a graph. It says the sine function has an amplitude of 15, a period of 4 pi, a phase shift of pi over 2. Now this means a phase shift that means left or right. Which one? Right, because it's positive. And a vertical shift, negative 10, so it goes down. Okay, the thing we don't know is if I give you a period, how do I get b? So we're going to come back up here. How did I find period from
2 pi over b?
2 pi over b. So if I'm solving that for b, because I need to know b, right? I would multiply both sides by b, wouldn't I? And then divide by p. So b equals, guess what? 2 pi over p. And period is the amount, the domain that it takes to complete one cycle, right? So you'll have to observe that on a graph. But this one just tells us. Okay, so amp is 15. So what variable is that? A. So that's A. Period. I don't put the period in my equation, but I have to find my what?
B.
B. So B equals 2 pi over 4 pi. So it will be 1/2. Okay. Phase shift, what variable is that? H. So this is H. And that's K. So I have Y equals 15. And it tells me sine on this one, right? Sine of B 1/2 parentheses x minus h, so minus pi over 2. If h was negative, it would be a what? Plus minus 10.
Woo!
Now, you're not done because this is not simplified. You have to do what with this 1/2?
Factor it in.
Distribute it in.
Yeah, that.
So y equals 15 sine of 1/2 x minus pi over 4 minus 10. So I want you to try the cosine one on your own. That'll make it easier to see a little bit. Can I start now? Okay, so did you guys get y equals 0.5 cosine of 6x plus 2 pi?
For some reason I got
5?
but I think I
Because you multiplied 6 times 3 instead of doing your
I changed 0.5 1/2.
that. What?
I changed 0.5 1/2.
Yes. And I would, if it was mine, I would have changed it to half as well. I do not like the decimals. They get lost in things. Gentry, leave your phone alone. Okay, questions on that, guys? Okay, so they gave me that, but I'm not going to be that nice. I'm going to give you the picture. Okay, so we're going to have to identify it. The things that are going to stay the same, and this is something you need to know, the same for both. Same for both. Sine and cosine would be A, wouldn't it? Is A going to be the same? Yes. B and K. They will be the same for both every time. Different and always, okay, different is going to be H, and that's an always. Okay? H will always be different between sine and cosine. Always. Because if it's not, it's the same curve, right? But the reflection is a sometimes. I ran out of room. Sometimes the reflection will be different and sometimes it won't. But what is always the same? A, B, and K. What is always different? H. What is sometimes different? Reflection. So when I say you're going to write a sine and a cosine curve, it's not like you have to do double work, is it? It's like I said, 1.5 work. So we're going to come down. Is it ready to come down here? Okay, so we're going to identify, and the way I'm going to do this is really what I want to see from you guys as well. We're going to identify the things that are always the same first. Got it? Okay, so A is the amp, right? Okay. And you can write A or you can write amp, either one. I don't particularly care which one you write. Now the amp is the distance from the middle of the curve, right? Okay, so the middle is here. And so it goes up 1 and down 1, so A is 1. Okay, you are going to have to identify period because you need it to get B, correct? Okay, so the period is the amount of space it takes to complete one cycle. So I start at 0, 2 pi. And B is 2 pi over the period. So 2 pi over 2 pi, so it is 1. And K. Okay, so 0. So put a 0. Don't ignore it, because if you ignore it, guess what you're going to do when you have to do it? You're going to forget it. Okay, so those are the things that are the same. So that's what I would expect on your paper. And then I would expect you to, I always do sine first. Some people look at it and say, oh, that looks like a cosine curve, so they do it first. I just always do sine first and cosine second. That's how I do it. I don't care which order you do it in, but you have to label it. So what I do is I go sine of theta, and I do H. Okay, so sine normally starts at the axis, yes? So it starts where? Pi over 2. So H is pi over 2. Now, this is my rule of thumb. You will have graphs that show you some stuff over to the left. You have to use the closest, not first, the closest starting point to the y-axis, whether that's to the left or to the right. Am I understood? Because honestly, there's infinitely many of these, and I'm not grading infinitely many equations. Got me? So if it happens to be even on the sides, like pi over 2 on the left, pi over 2 on the right, I will take either one. Okay? But if there is one closer, you have to use it. I know people that will go all the way like over like 6 pi to get a positive one. And I'm like, no. Okay, is it reflected starting right here? Nope. And I would put a little dot there so you know that's where you started. And I just put no reflect. Just so I know I'm checking it. I don't know why I was down so low. Okay, so I said the H was always different and the reflection was sometimes different. So do I have every piece of this covered already? Yep. So plug it in now. Let's see if you can do it on your own. Okay. No, I just plugged it in first so you saw it. Today I'm going to do that so you can see it. And so you should end up with y equals sine of x minus pi over 2. Correct? You can put the 1 in front. I would not put the 0 in the back when you're done. Okay. I would definitely, for today, for a while, put everything in there so you see it and you account for it. Does that make sense? Okay, so now we need to do cosine. So we guess what we do? We label it. And what is my h? Nope, there is none. It's 0. And we're obviously using this point right here, correct? So is it reflected? Yep. This one right here. Okay, h. Well, you go to starting point. Cosine always starts at a max or a min, yes? So that would be the first min. And cosine normally starts up and goes down. And this one is starting down and going up. So it's reflected. And so I didn't move off the y-axis, so my h is 0. Do you know how we found it for sine? Sine normally starts at the axis of the curve. So the first time I hit it is right there. Okay, so I'm assuming you're already plugging it in. So we get what? Negative cosine of x. So it's just a normal untranslated curve, right? You guys have the picture, so I'm not going to worry about zooming in enough so you can read all those little numbers from far away. Questions? Is it that difficult to do? No. It's going to be sometimes we have to think a little bit more about the period and things like that, but if we identify everything before we start, are we good? Okay. So the next one. Amp. 2, because it goes from the middle, because the middle's still at 0, isn't it? Period. Yep. 2 pi. So that means B is what? 1. And K? This is the middle of the curve. Where's it at? 0. K is the middle of the curve, the horizontal middle. Okay, so sine of theta, H. Okay, so sine starts at the middle, right? So right here is my point, so 0. It's reflected. So we have negative 2 sine of x. Is that what you guys got? Oh, I should have switched colors and I didn't. Sorry. I know. So cosine. Cosine, my first minimum or max is right here, isn't it? You may not make a graph and come this way. Got it? If you can't see it, you can't use it. Do not make it up. Because you don't know what it does out there.
I think I know what it does out there.
Oh, and there is something we need to add to this, and we'll do it here. Because what actually can happen is we can take sine and cosine curves and add them and multiply them and do funny things with them. And so you will get them that look nice and neat like this, but then when they go out, they'll like squiggle, squiggle, squiggle. Like, so we're only writing this from 0 to what can we see? We can see 0 to what? 2 pi. So we'll write the domain that we can see, and we should have done that on the first one, and I forgot to. We will say this is the equation for 0 to 2 pi, and we're not guaranteeing anything outside 0 to 2 pi. Make sense? Or whatever they picture. Okay, so what is my h? Pi over 2. And is it reflected? Yep. So on the last one was reflected, one wasn't, and on this one, they're both reflected. So that's the sometimes, sometimes not. I get -2 cosine of x minus pi over 2. You guys get the same thing?
Yes.
Okay. Now, I usually do the domain right after I do this because the domain is good for everything, right? So we're just going to put d for x such that we are from where? 0 is less than equal to x, which is less than equal to 2 pi. Now it's only 2 pi because what is pictured here? I can see 0 to 2 pi, correct? If they had, yes, yes, we should do it on the first one. What's the first picture? 0 to 2 pi. It will be different, and sometimes you will have negative numbers. So whatever the picture is, you put the minimum, less than equal to, and the max that you see on the x values. I don't care about the y. I don't care about that. I'm only saying these two equations, I'm only verifying them for this much. Got it? You guys want to try this one all on your own? Can I start? Okay. How'd sign go? Good?
I didn't look at the, that was 2 periods.
You didn't notice that the period was only pi, did you?
Oh, yeah.
Yep. Because how do I know the period's only pi? Because it starts repeating at pi, doesn't it? Yep. That's why I wanted you guys doing it.
No, I don't understand how to H for cosine.
Okay, so h for cosine is going to be right here, isn't it? Right there. Okay, so we know that everything are cut in equal parts, right? So if this is pi over 2, this is going to be half of pi over 2, yes? So for cosine, we're going to have pi over 2 times a half, which was going to be pi over 4 for your h. I just was showing you how I got it. If you just put pi over 4, I'm good with that. And is it reflected? No. So it's not everything is going to be marked, is it? So I have to use what I know about how these work, that they're equal parts and they're cut into equal parts.
So when you're doing the domain,
Uh-huh.
is it just the last number on the graph?
Yep. It's the last of the picture, not the period. It's not the period, it's the domain. It's the x's that I'm seeing. Okay, so did you get cosine of 2x minus pi over 2? Okay.
Wait,
You did not.
why would it be 2x minus pi over 2? Because we take 2 times.
Because you have to take 2 times pi over 4, which will give me pi over 2. So this will help us with our factoring. Some of us were struggling with our factoring. Hoping multiplying it in will help us see that relationship. Okay. Yeah, I would do the domain right after you do everything else that's the same so you don't forget about it.
X such that 0 is less than or equal to x equal to
Pi. Yep, 2 pi. The p? Okay. Okay, so this one has been, we've got a what going on this one? We got a k. It moved to -2 because, and if you don't know where that's at, now watch. If you don't know where that's at, how can I figure out the?
Count them down until they meet together.
Okay. So right here is the middle, and I gave you something you could write on. You can't write on the book. Do not write the axis on the book because. So a equals 4. Yep. And then p is 2 pi because you only have one period here. So b is 1, and our k is what? -2. And then domain is
0 to 2.
now it's gonna feel like you write 0 to 2 pi a lot, but don't just assume it's 0 to 2 pi. Because if you look at the next ones, it's not 0 to 2 pi, is it?
Yeah.
You guys already going?
I'm working.
Okay.
So my h for
Sine starts at the x-axis, the new x-axis, so it's 0. So did you get 4 sine? Oh, not done? Okay, I won't talk. What is up with my pen?
good for you.
I'd be done if my pen would work. It's brand new. So, did you get 4 sine of x minus 2? Okay.
Wait, for the cosine reflex, you have to go down.
Where's the closest cosine?
The first would be pi 2.
Yep, it'd be pi over 2. So is that reflected? Nope. Okay, so did you get 4 cosine of x minus pi over 2 minus 2? Okay, Now, you notice I keep writing this 1 even if it's a 1, because if you don't do that, if you don't write it when it's a 1 when they're easy, what's going to happen when they get harder and more complex? You're going to forget it, and you've got to distribute it. You had to learn you had to factor it to graph, right? So now you have to distribute it. Okay. You guys want to be on your own again? Okay. And you do have to have a y equals. If you do not put a y equals, it's not an equation, is it? No. You could put f of x equals as well if you'd like, but most people will put y. You get y equals sine of 1/2 x plus 1. Sadie, did you say no? Okay, Connor, what did you do? Did you do cosine? No, your k is 1. The k is the axis. The h is the left to right movement. So this is your new x-axis, and sine is starting right here. And so did we get cosine of 1/2 x minus pi over 2 plus 1? How you feeling about this stuff, guys? We're good? Okay. So I'm going to tell you, I don't care what your directions say today, this is what you're doing on the 8 graphs. Got it? Don't even read the directions because the directions are like a paragraph. Do this. Okay? Don't do that. Do that. You guys are already working on 8 and 9? Yes. Well, let's see. Let's look at this. Okay, because we really don't have like where it starts and stops, do we?
Can't just continue on.
Right.
No, it's only
So
what
what
we
you
saw.
should do is remember that these are in quarters, right?
Yeah.
Okay. So let's go through this first. Okay, so the amp is what? 4.
Yeah.
And then we got to figure out the period, right? Well, if I went from here to here. That didn't do me much good, did it? Well, I do know, well, I could tell you that's exactly half between 2 and 3, yes? So that would be, what, 5 pi over 2? Yeah? So if I wanted to take it for period, I would take 5 pi over 2 minus pi, which would be 2 pi over 2. Yes?
Wait,
Yeah.
minus pi, that'd be 3 pi.
No. No, not the answer. Not the answer. I have 5 pi over 2 and I need to minus pi, but I have to have common denominators. So 2 pi over 2, not the answer. Okay, so it's 3 pi over 2, and that's 1/4 of this, yes?
We take that times 4.
So we take that times 4. Okay, no, you will have to do that. Okay, from here to here is 1/4 of this graph, yes? Yes. And this is 2.5, which would be 5 pi over 2. And then I have to subtract pi, which would be 2 pi over 2. So 3 pi over 2 is 1/4 of this. So I multiply the whole thing by what? 4. So that gives the period to be pi, just what? 6 pi? So sometimes you're going to have to do a little work to get the period, right? But remember things, if you can see half of it, you can double it, can't you? If you can see 1/4 of it, then you multiply it by 4. I don't think I'd be going for 1/3 of it, but go for halves and quarters.
So the domain.
Wait, B is what?
Okay. 1/3.
1/3. And K is
0.
0. And the domain?
That's such that 0 is less than or equal to x is less than or equal to 6 pi.
Nope. The only thing marked.
5 pi.
5 pi.
That's what I was going to ask you about. You said minute.
Yep, that's what I said. Sorry. I should have let you finish. Okay. Only what is labeled. We can assume, but we don't even have that next dotted line, do we? Nope. So we can only put down what is labeled. And then you're off and going. Did the hard part already, right? Okay. It was, so sine starts over here, but we don't know exactly where that is, do we? So we have to do over here, and that was 5 pi over 2. And then it would be reflected. See, I'll have people go, oh, well, I can come back here and make this up, but does it tell me where it is? Nope, and I only said from 0, didn't I? So you can't use stuff that doesn't exist in the domain. So we get what? -4 sine of 1/3 x minus 5 pi over 6. Okay, now we do need to do cosine, but I want to do the first part on this, don't you think? Okay. So finish out doing the cosine later, like add that to your homework, like one little thing. Okay, so let's look at this one. What's the amp on the next one? Well, where's the middle? Well, this would be -6. They do have the dotted line, so we know it's -6, right? And so we go 1, 2, 3, 4, 5, 6, 7, 8. So -2. So -2 is my middle, right? So the amp, yes, that will be K. A is what? 4. Period. Yes, pi over 2. I was in my brain, I was thinking you said 2 pi. Because from here to here, it's pi over 2, correct? So B is going to be 2 pi times 2 over pi, right? So it will be 4. And K will be -2. Yep. Yep. 0 to pi. And then how are we going to figure out, well, cosine's easy. It's h is 0, yes? What about sine? How are we going to figure out sine?
I don't know.
Well, from 0 to pi over 2 is the whole thing. So that has to be a quarter into it, yes?
Yeah.
Okay, or this one's, we could do a quarter. Nope, we'll do a quarter into it. So we have to find the h for sine. So the h for sine is going to be pi over 2 times 1/4. So pi over 8. And it's going to be what? Reflected?